Most artificial intelligence models don't actually think. They give you an answer, but only after stitching together pieces of text that feel familiar. And the newer ones? They're called large reasoning models, or LRMs. These models try to impress by showing their step-by-step thought process before delivering a final answer. It looks like real thinking, solving problems bit by bit like a human would. But what if it's all just an illusion? Apple decided to find out. Instead of just looking at final answers, Apple's research team went deeper. They wanted to know if these so-called reasoning models were actually reasoning or just pretending. So they built a series of experiments using classic puzzle environments that computer scientists have studied for decades. Tower of Hanoi, checkers jumping, river crossing, and something called blocks world. Each puzzle has increasing difficulty that scales logically. You add more disks or more pieces or more people. Same logic, harder task. That makes these puzzles perfect. Every step can be tracked and verified. The results? They were surprising. To keep things clean, Apple made sure these puzzles hadn't shown up in the model's training data. Then they ran models with and without reasoning features enabled. Same size, same weights, same architecture. Think of it as testing two versions of the same brain, one that explains its thinking and one that doesn't. They compared Claude 3.7 Sonnet with and without reasoning. Same with DeepSeek R1 and V3. Each model got the same massive 64,000 token budget. Every puzzle variation was run 25 times to reduce randomness. The researchers tracked how many times the models got the right answer, how often they made correct steps, and how much thinking they actually did. In simple puzzles, the regular, non-reasoning models performed better. They gave fast, accurate answers without wasting tokens on long explanations. But as the puzzles got harder, the reasoning-enabled models started to pull ahead, especially on medium difficulty tasks. However, once the puzzles got truly difficult, all the models, reasoning or not, collapsed. Accuracy dropped to 0. Claude 3.7 thinking could handle up to 8 disks in Tower of Hanoi. Try 10 disks, it failed completely. DeepSeek R1 didn't even get that far. When Apple pushed Hanoi all the way to 20 disks, requiring over 1 million steps, none of the models could keep up. Same story in checkers, river crossing, and blocks world. But one of the strangest discoveries was about the model's internal effort. You'd assume that the harder the problem, the more effort the model puts in. But that's not what happened. Initially, yes, reasoning effort increased as difficulty went up. But then suddenly, it dropped. DeepSeek R1 would use 15,000 tokens on a moderately difficult puzzle. But when the puzzle got harder, it dropped to just 3,000. Even though it still had plenty of tokens available. This wasn't a resource problem. It was a reasoning breakdown. Apple called it a counterintuitive scaling limit. To test further, researchers gave the models the full solution. They didn't even have to figure anything out, just follow step-by-step instructions. Even then, they still broke down at the same point. That's not about memory. That's a failure to execute a long sequence of logic. Claude 3.7 thinking managed about 100 correct steps in a 10-disc Hanoi puzzle before failing. In river crossing, it failed after just 5 moves, despite the full solution needing only 11. The issue wasn't in finding the answer, it was in staying on track while getting there. And when this research hit the internet, the AI world exploded. Gary Marcus, a well-known critic of neural networks, called the findings pretty devastating. He pointed out that even in 1957, Herb Simon coded a working Hanoi solution. Today, there are hundreds of functioning algorithms. If AI can't even follow those, how can it possibly reason? But not everyone agreed. Kevin Bryan, a professor from the University of Toronto, argued that what Apple exposed wasn't a failure of intelligence, but of design. These models are trained to avoid overthinking. Why? To save time, reduce costs, and keep server load down. He believes that if we let the models use more tokens and think longer, they'd perform better. They're not failing. They're choosing not to try. Sean Godke, a software engineer, echoed this. He said DeepSeek likely recognized it couldn't complete a 1,000-move puzzle and just stopped trying. Meanwhile, AI researcher Simon Willis added another layer. He said models like GPT aren't designed for step-by-step algorithmic tasks. Using something like Tower of Hanoi to test reasoning is fundamentally flawed. These models might never be as efficient as proper rule-based algorithms. And even Apple admitted, these puzzles only test a narrow slice of what reasoning really is. But that narrow slice still revealed cracks. Take Claude's behavior. On easy puzzles, it often got the correct answer early in its thinking, but then wasted time exploring wrong paths, essentially overthinking. On medium puzzles, it found the answer later in its reasoning. And on hard puzzles, it never found it at all. Not once. That shift, from early success to late success to total failure, was consistent. It showed up in every puzzle, every model. Apple visualized it in a chart labeled Figure 7, but the message was clear. The illusion of reasoning collapses under pressure. Now fast forward to Apple's Worldwide Developers Conference. You'd think they'd lead with a bombshell from this research. Instead, they unveiled a design overhaul. Liquid glass, a translucent aesthetic that spans iPhones, Macs, and the Vision Pro headset. The animations are fluid. The interface is elegant. It runs at 120 frames per second. But Wall Street wasn't thrilled. Apple's stock dropped 1.2%. Why? Because the AI features they showed weren't revolutionary. There was real-time voice translation during phone calls, offline without cloud connection. Impressive, yes, but not groundbreaking. You can also now tap a screenshot to send it to ChatGPT for a summary, or ask ChatGPT to generate images in the Photos app. But the big Siri upgrade everyone was waiting for, the one where it scans emails and schedules things automatically, was missing. Apple says it's still not ready, and behind the scenes their researchers were wrestling with bigger questions. Apple even tested OpenAI's 0.1 and 0.3 mini models. The results? Same story. They did fine up to 8 disks in Hanoi, failed completely by 10. This echoed a recent study by the US Math Olympiad team. When given brand new math proofs, never seen before, those same models scored under 5%. Only one even reached 25%. None got a perfect score. When the answer already exists in their training data, AI performs well. But when a truly new problem appears, the illusion breaks. And this goes beyond puzzles. Apple ran math benchmarks using the same models on datasets like Math 500, AI-Me 24, and AI-Me 25. On older datasets, reasoning and non-reasoning models performed similarly, but on newer ones, reasoning models finally pulled ahead. Strangely, humans did better on AI-Me 25 than on AI-Me 24, but AI did worse. Why? Probably because older datasets had leaked into training data. The newer ones revealed the truth. One last twist. Claude 3.7 thinking could do over 100 steps correctly in Hanoi before failing. But in River Crossing, it broke after just 5 moves, even though the whole solution only needed 11. Why the difference? Simple. There are way more examples of Hanoi online, especially with 10 disks. River crossing problems with more than 2 pairs of people are rare. Without examples to copy from, the model didn't know what to do. That's the bottom line. What we're seeing isn't real reasoning, it's pattern recall, and once those patterns run out, the system breaks. So, is AI fake? Not exactly. But it's not what most people think. Apple's research shows that today's AI systems can't reason their way through complex tasks. Not yet. Their thinking unravels under real pressure. Some experts say we can fix this with more tokens, better training, and smarter prompts. Others believe we've hit a wall and need a whole new approach, but either way, the illusion is getting harder to maintain. Did Apple just expose the truth behind AI's limits? Or are we just looking at growing pains on the way to something better? Let me know what you think in the comments. And if you want more deep dives into the real world of AI, don't forget to hit that subscribe button. Thanks for watching.